Alright, welcome to application 2C-3, focusing on rate of change. Our learning target is that I can find and interpret the rate of change. So we kind of have a hodgepodge of examples in this particular application. So I'm going to walk through some of them. I'm going to do the actual problem with you guys, and some of them I'm going to do an example that's similar because you only have a couple of them to do, or maybe even only one of them to do. And I want to leave some for you to have the privilege of trying. I won't want to take out all that fun from you guys. Alright, so we're going to start out looking at number 1. So below we're given the graph and table for two runners running the 400-meter hurdle races. We want to know in part A, which runner has a faster average of speed for the first 9 seconds. So what we are going to need to do is compare the rate of change between runner A and runner B. So I'm going to look first at runner A, if no other reason than because he comes first alphabetically. Alright, so what we've seen people get confused on is they get overwhelmed by the 3 columns. So what I would recommend you guys doing is just covering up the one that you guys are not looking at and ignore it until you are ready to look at it. So I'm just going to shade over this, and what I would do if I were you is I would just put another sheet of paper over it or something like that, because obviously you're going to need to be able to see underneath it, and you can't erase as easily as a smartboard. But I would just ignore that information for now and focus on just the time and runner A. So we are looking for the average speed for the first 9 seconds. So we are going to need 2 ordered pairs. So our ordered pairs are going to be based on the interval that we're looking at. We want the first 9 seconds, so we're looking at from the time he begins until those 9 seconds have passed. So my first ordered pair is going to be 0, 0. I'm getting that from right here. And my second ordered pair is going to be 9 and 120. So what I'm going to need to do is I'm going to need to use my slope formula. Remember, it is on your formula sheet, which you will be able to use on the milestone in your mastery checks in the test. But it is y2 minus y1 over x2 minus x1. And I apologize that the marker's lagging a little bit tonight. So what we're going to have to do is we're going to have to plug this in. So I'm going to do 120 minus 0 over 9 minus 0. And when I simplify, this one ends up being pretty easy. I'm going to end up with 120 divided by 9. And when I type that into the calculator, once this spits out the writing that I've already done, it's going to give us about 13.3. And you can round to 1 decimal place on this. Alright, so what I want to do now is I want to look at runner B. I'm also going to need ordered pairs for him. And I'm going to do the opposite of what I did when I looked at runner A. This time, I'm going to go ahead and I'm going to cover up runner A. And I'm going to look at just the time and runner B. So I'm going to look at ordered pairs again. And in this case, again, remember we're looking at runner B. Alright, so we're going to have 0 and 0 again. And we're going to have 9 and 120 again. Now notice this is not going to happen every time where we get the same thing. If you look here, they start to differ when you're looking at both sheets, or both columns. But we are going to end up doing the same thing. 120 minus 0 over 9 minus 0. And that's going to give us 120 divided by 9, which is again going to give us 13.3. So in this case, which runner had faster average speed for the first 9 seconds? We're going to say that it was a tie. And if you look at the graph for the first 9 seconds, it does look like at 9 seconds that they're at the exact same spot. Now, even though one runner ran a little bit faster for a while, looks like runner A, runner B caught up to him, and they end up in the same spot at 9. So even though they ran at different rates for a little bit, their average rate of change was the same. Alright, so go ahead and continue on with that for the rest of that particular problem. and then we'll take a look at the next problem. Alright, so we're going to take a look at that graph that it gives you, and this shows the United States population from 1900 to 2010 as recorded by the United States Census Bureau. So we want to know what is the rate of change in the population from 1900 to 2000, and is this greater than or less than the rate of change in the population from 2000 to 2010? So I'm going to figure out the first one with you guys from 1900 to 2000, and I'm going to leave it up to you guys to find from 2000 to 2010. Now I need ordered pairs, and I want over the interval 1900 to 2000. So what I'm going to do is I'm going to go up to my graph, and I'm going to look at where x is 19,000, or not 19,000, sorry, 1900. So I'm going to go up to my graph at 1900. It looks like my y value is going to be 75. Now I'm going to have to do the same thing with the year 2000. I'm going to go to where the graph is 2000. And I'm going to go up, 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 and it looks like it's right about at 275. Again, I got those ordered pairs from the graph. So I'm going to plug it into my slope formula. I'm going to do y2 minus y1 divided by x2 minus x1. Alright, 275 minus 75 is going to give me an even 200. And 2000 minus 1900 is going to give me an even 100. So my rate of change is going to simplify to be 2. So you guys do the same thing for 2000 to 2010, and then write a little sentence comparing the two as to which is greater and which is less than. Alright, moving on. You have a problem that looks very similar to this in the application. We're going to do a slightly different version because there's only one problem for you to practice, so keep in mind this is not the actual problem. This is an example problem for you guys. So for f of x equals negative 3x plus 4, we want to find the rate of change on the interval from negative 3 to 6. So what this is giving me an interval of x values. It's telling me my first x value is going to be negative 3, and my second x value is going to be 6. Now the way that I know that these are x values and not an ordered pair is because I have the square brackets as opposed to the round parentheses. If these were round parentheses, it would be an ordered pair. But since I have the brackets, I know that this is going to be an interval. So this gives me negative 3 as my first x value, and 6 is my second. So now we have to figure out how to find our y's. So the way we're going to do that is we're going to take these x values and we're going to plug them into the function. So first I'm going to have to find f of negative 3. So I'm going to plug in negative 3 where I see the x, and I'm going to simplify that. So f of negative 3 is going to equal negative 3 times a negative 3, which is a positive 9, plus 4, which is going to give me 13. So my y value here is going to be 13. I need to do the same thing with the 6 now. So I'm going to do f of 6 is equal to negative 3 times 6 plus 4. So f of 6 is going to equal negative 18 plus 4. So f of 6 is going to equal negative 14, which is going to give me my second value here. Now, we need to plug this into our slope formula. I like working with not having to do a double negative, so I'm going to make this my y2 and y1, or y2 and x2 and y1 and x1. So I'm going to do negative 14 minus 13. Since I put the 14 first, I have to put the 6 first. 6 minus a negative 3. Alright, now, negative 14 and negative 13 is going to give me negative 27. Now, notice I have two negatives here, and two negatives are going to make a positive. So I'm going to do 6 plus 3, which is going to give me 9. I'm going to have negative 27 divided by 9, and get x is equal to negative 3. And that will be my rate of change over that interval. Now, if we want to think back, we know that this is a linear function here. And we remember that linear functions have a constant rate of change. So the answer we found here should match the slope here in the slope-intercept form, and we see that we actually do indeed match the -3 to the -3, which is pretty cool. Alright, one last example. You and a friend are just trying to decide which bowling alley to go to on a Friday night, and this is going to be another one of those where this is an example problem. It's not on your actual application, but you have one very similar, but this will give you an example to work that one since it's the only one on there. Now, Clarksville Lane is going to charge you $6 for, and that should say a bowling game, and $2 per food item. We're going to have Star and Strikes prices represented by this table here. We want to write an equation for Clarksville Lane and Stars and Strikes and compare their rate of change and initial cost. So for Clarksville Lane, I know that if I am bowling one game, I know I'm going to pay $6. Alright, so I'm going to give myself a little bit more room here. So I know that f of x is going to cost me at least $6. Alright, I'm also going to pay $2 per food item. I'm not sure how many food items I'm buying, so I'm going to do 2x. Now with Stars and Strikes, I need to look at this a little bit differently. They give me a table and I have to write an equation. Alright, now to keep these apart, just like we've mentioned before in the function notation video, we can name these with different letters. So I'm going to call this one g of x. Now if we're thinking about this, our y-intercept, if we were writing this equation, would be where x is equal to 0. That's where it crosses that vertical axis. So where x is equal to 0, I'm going to have 3. That is my initial value. Alright? Now I have to see what's happening every time. In this example, I go from 3 to 6 to 9 to 12 to 15. Each time I'm going up by 3. So as x increases, I am going up by 3 every time. So just to recap, this is my initial value. And I found that by looking at where x is equal to 0. And then this is my change every time. Alright, now, we want to first compare their rates of change and the initial cost. So looking at rates of change, that's our slope, or what's happening every time, rates of change. Alright, my rate of change on the first one is the number in front of the x. It's going to be 2. And on this one, it's going to be 3. So Stars and Strikes will have a higher rate of change. Alright, because 3 is bigger than 2. Now if we want to look at initial cost, that's what we are paying up front. So in the first example, we had to pay $6 to bowl at Clarksville Lane. At Stars and Strikes, we're only going to pay $3 because we would have bought 0 food items. Our initial cost would be $3 to bowl. So our initial cost, Clarksville, will be higher. Alright, now the last question we were asked is which bowling alley is cheaper if you want to see the movie and also get a pizza and ice cream? So we are buying 2 different food items. So if we're buying 2 food items at Stars and Strikes, we can look over at our chart and see that we'd be paying $9. So at Stars and Strikes, we're paying $9. Alright, at Clarksville, we would have to plug in the 2 here. So we would do 6 plus 2 times 2. 2 times 2 is 4, and 6 plus 4 is $10. So at Clarksville, we would be paying $1 more. So our answer as to which one is cheaper would be Stars and Strikes. One final thing to point out, that just because Clarksville Lane was more expensive in this particular case and Stars and Stripes were cheaper, because they have different rates of change and different initial costs, that will change depending on the number of food items you purchase. So eventually there's probably going to be a point where they switch as to which is cheaper and which is more expensive. That's why it's always important to take into consideration all the factors and not just assume that since it's cheaper in one case that it's necessarily cheaper in the other. Alright, so that wraps up today's application. Complete application 2C-3 and start studying for your mastery check. As always, let us know if you need any help. Good luck with the application and the mastery check, and we'll see you in 2C4. See you guys later.